Okay, so sometimes radicals take on the form something like square root of 3 plus 4. And first off is remembering that these cannot be added together. This is an irrational number. This is a rational number. We cannot put those together. We could estimate them and put them together, like what the square root of 3 is around 1.7 something. And so we could get an estimate for this answer, but it's irrational, so we can't actually go through and add that to a rational number. So we leave them in what we refer to as a binomial form. This could be considered a binomial form, two terms. You could also have two radicals together, like root 2 plus root 5. Those can't be added together. So you have to be careful with those. Well, since we can end up with these radicals that look like polynomials and that they've got multiple terms strung together, added together, or subtracted together, we have to do operations on them. So for example, we're going to have problems like this, where we have the square root of 2 plus 3 times the square root of 6 plus the square root of, let's say, 15. And we need to go through and multiply this together. Well, the way that we multiply it together is exactly like we did before, which is when we multiply the binomials of two polynomials together, or two expressions. And so we do square root of 2 times square root of 6 to get square root of 12, square root of 2 times square root of 15 to get square root of 30, square root of 3 times square root of 6 to get 3 times the square root of 6, and 3 times square root of 15 to get 3 times square root of 15. Then we need to go through and add, simplify, make sure all the radicals are simplified. And so square root of 12 just turns out to be 2 radical 3 because 4 goes into 12. Square root of 30 can't be simplified. Square root of 6 can't be simplified. Square root of 15 can't be simplified. We then look for like terms. None of the radicals are the same. So this is our answer. Another example would be one like this. 2 radical 3 plus 4 radical 2 times radical 3 minus 3 radical 2. So in this example, when we multiply it, 2 radical 3 times radical 3, you can either just immediately notice this is going to be the same as 2 times 3, or you could write it as 2 square root of 9, which is what I'll do this time. But you could simplify that down because you know radical 3 times radical 3 equals 3. 2 radical 3 times 3 radical 2 is going to give you minus 6 radical 6. As always, be careful with your negatives. 4 radical 2 times radical 3 is going to give you 4 radical 6. And then 4 radical 2 minus 3 radical 2 is going to give you negative 12 times radical 4, or square root of 4. Simplify 2 radical 3 just turns out to be 6. These two are already simplified, so I'm going to go ahead and combine those like terms. Radical 6 can't be simplified any further. And so negative 6 root 6 plus 4 root 6 is going to give you negative 2 root 6. And then this one is going to give you negative 24 because square root of 4 is 2. And so now we got to go ahead and combine these like terms to get negative 18 minus 2 root 6 as your answer. And so the correct answer there is negative 18 minus 2 root 6. It's an interesting thing when you get 4 terms, 2 terms and 2 terms, and end up down to 2 terms when you multiply together, because a lot of things, and that happens a lot in these kind of problems. A couple more of these kind of examples. One like this, where you have, this is a somewhat common one, 2 root 3 minus 5 times 2 root 3 plus 5. Hopefully you recognize what this looks like, right? It's very similar to this. And when I do x minus y times x plus y, this is a specific kind of problem. The difference of squares is the result, right? Because you get x times x is x squared minus y squared. That actually becomes very useful to us. Let's see it play out. You can either go straight to the answer if you want, or you can multiply things out just so you can see it. So 4 root 9 minus or plus 10 root 15 minus 10 root 3, sorry. Right, 2 root 3 times 5 gives you 10 root 3, minus 10 root 3, and then minus 25, those canceled out. 4 root 9 is 12, and so you get 12 minus 25 equals 13, negative 13. The really powerful thing there is we multiplied two irrational numbers together and got a rational number. And that's kind of an incredible thing that we did. We took these two irrational binomials, and by using the difference of squares and the powers of the difference of squares, we've got a rational number. And we're going to use that again later. I have to do one more example here of these. And so the last example is this one of the multiplying binomials. If you had the square root of 2 plus the square root of 5 squared, remember, this is not 7. It is instead radical 2 plus radical 5 times radical 2 plus radical 5. So yeah, you're going to have square root of 2 times square root of 2, which is 2, but you're also going to have your square root of 10s in here from the middle. And then square root of 5 times square root of 5 is just 5. And so you end up with 7 plus 2 square root of 10 as your answer. So just don't forget, you know how to do all that stuff with binomials. You just now are applying it to radical form. All right, the second part of the lesson is what's referred to as rationalizing the denominator. And so when you rationalize a denominator, that you do exactly what it's saying, and that's that you're going to make our radicals in denominators rational numbers. And we do that by taking advantage of the fact that we can multiply both an expression by 1 without changing it. We've already done this a little bit, right? We talked about problems like this, 10 times the square root of 5. When you have 10 times the square root of 5, you multiply the numerator and the denominator by square root of 5. And that works because square root of 5 times square root of 5 equals 5. And so we've rationalized the square root of 5 to 5. And then we would simplify to 2 root 5. Well, with binomials, you take advantage of what we discovered when we did this perfect difference of squares problem. If you had a problem like this, where you've got 4 over, let's say, 4 minus plus root 7. And so 4 over 4 plus root 7. If you want to rationalize this denominator, which is what we're going to ask you to do, you need to multiply the numerator and the denominator by the same thing, because that gives you 1, so you can multiply by 1, such that the denominator becomes a rational number. And there's always two ways to do it, and it's called the multiplying by the conjugate. And the way you multiply by the conjugate is to change one of the two signs to a negative. The best way to do it is to change the smaller one to a negative. Right, in this case, you've got 4 plus root 7, so we just changed it to 4 minus root 7. Root 7 is somewhere between 2 and 3, so it's less than 4. And again, if I multiply the denominator by something, I must multiply the numerator by something. So the numerator is just going to be, and don't forget you're multiplying by a binomial, so it's 4 times 4. And then the denominator is just going to be, or then 4 times root 7 is just 4 root 7. The denominator, now this is the part where if you can remember that the x minus y times x plus y is simply the first term squared minus the second term squared. Well, the first term squared is 16 minus the second term squared, that's 7. That gives me 16 minus 4 root 7 over 9. And that is the correct answer to this problem. Now, if you would have chosen, you could have done this by, instead of multiplying by 4 minus root 7, you could have multiplied by negative 4 plus root 7, or root 7 minus 4. And the only difference is, when you did this, you would have got negative 16 plus 4 root 7 all over negative 9, because it would have been negative 16 plus 7. And so your signs are just all switched. And so you could switch them back to get a positive denominator. So it doesn't matter which one you choose. It's just simpler to always choose the bigger one, or the smaller one, to be the one that you change to a negative. Okay, a couple more examples of this. If you had a problem like this, where you have 3 over square root of 2 plus square root of 6. Well, for this one, you're going to multiply the top and the bottom by square root of 2 minus square root of 6 over square root of 2 minus square root of 6. So the numerator is just going to be 3 square root of 2 minus 3 square root of 6 all over 2 minus 6. if you notice, what I did on this one is I didn't follow my own rule in that I made the bigger one square root of 6 the negative. And so that means I end up with a negative here in the denominator. To clean it up and make it look better, we're going to go ahead and change the sign of everything. We're going to make that negative square root of 6 positive, the 3 square root of 2 negative, and the negative 4 positive. And so that is our answer. All right, one more quick example, or two more quick examples. So if you have, let's say, 12 over 3 minus the square root of 5. Okay, so on this one, you need to multiply by the conjugate of the denominator. Well, the conjugate of the denominator is just going to be 3 plus the square root of 5, right? We take the one of the two and change their sign from to the opposite. So you could have done negative 3 minus root 5, but that gives you lots of negatives. So it's better just do 3 plus the root 5. So then we multiply the numerator by 3 plus root 5, so that we're multiplying by 1. That gives me 36 plus 12 root 5 all over 9 minus 5. So that gives me 36 plus 12 root 5 all over 4. Now, on this one, 36 and 12, the rational coefficients, are both divisible by 4. And so you need to simplify this further. You can simplify each of those separate, or you could think about it as taking a 4 out of this and getting 9 plus 3 root 5 by factorization. However you want to think about it, your final answer for this problem needed to be 9 plus 3 root 5. Okay, and that's how you go through and simplify binomial denominators and rationalize denominators. You just have to be careful. It's nothing new. It's just applying things that you already know.